students, I am Lalita Yadav from Hari Science and Maths Academy. Please like and subscribe the channel for the new videos whenever the videos are uploaded on the channel, so that you can get notification after the subscription of the channel. Now in the last lecture we will discuss the class 8 kinematics part 2, and yesterday I gave you the one question, that is, the driver of a passenger train moving at a speed of 90 km per hour observes a good train. एक पैसेंजर ट्रेन का ड्राइवर जो है उसने क्या देखा, सेम ट्रैक के ऊपर एक गुड्स ट्रेन जो है वो रेस्ट कर रही है, तो उन दोनों ट्रेन्स के बीच में जो डिस्टेंस है दैट इज़ 250 किलोमीटर. सो द passenger train driver immediately applies the brake. Now what you have to calculate is what should be the minimum retardation of the passenger train so as to avoid collision of the two trains. The value given is, initially the passenger train is moving with a speed of 90 km per hour. So given is u is equal to 90 km per hour, and after applying the brake the passenger train comes at the rest and the final velocity is 0, and the distance or the displacement we can say it is given as 250 meter. As the unit of velocity and displacement are different, so we have to convert the unit in the same, right? So u is 90 km per hour. We have to convert this unit in same, that is meter per meter. If the displacement velocity is in meters, then the time is converted into seconds. Firstly, we convert the u, that is 90 km in meters, it multiply by 1000. Per hour means 1 divided by 60 minutes, and in every minute there are 60 seconds, right? 0, 0, 0, 0. Now this is 30, this is 2, 2 is 5, 6, this is 5. Value comes out to be, initial velocity comes out to be 25 meter per second, right? Now what we have to calculate to find is acceleration. What we have to find is acceleration, but the time is also not given over here, and the displacement s, that is 250 meter, is given. As we know the equation, solution is v is equal to u plus a e. In this equation already two terms are unknown, one is acceleration, second one is time. So for that we have, for calculating the acceleration, first we have to calculate the time. How we calculate the time? As the displacement is or distance is given as 250 meter, and we know that s is equal to distance is equal to speed multiply by time. Now the speed is from 25 meter per second comes to 0 meter per second, right? So the speed is variable. In that case, when the speed is variable or velocity is variable, we calculate the average velocity. How is average velocity is calculated? We average is u plus v divided by 2, right? This is 0 plus 25 divided by 2, that comes out to be 12.5 meter per second. As given, distance given is 250 meter, Here the speed is average speed. We put the average speed here, average velocity here. That is 12.5. As the unit of both are same, distance and speed unit are same. Distance is in meter and speed is in meter per second. Only the time is unknown. Then from here time is 250 divided by 12.5. It comes out to be 20 seconds. Now put all these values in equation number this. Equation number 1, V is equal to U plus AT. V is 25 meter per second, U is 0 and A is the unknown and T is 20. Right? Sorry. V is 0. As V is 0, U is 25. So A is 0 minus 25 divided by 20. It comes out to be minus 25 divided by 20. That is minus 1.25 meter per second square. Here, as A denotes the term acceleration, the value comes out to be minus. It means that it is the value of the retardation. Right? In question, it is also asked what is the minimum retardation value so that the train does not have collision. So retardation comes out to be in this case is 1 point. Retardation comes out to be 1.25 meter per second square. This is the solution of the question which I asked yesterday in yesterday's lecture. Now the next topic is equation of motion. There are 3 equations of motion which is included in your syllabus. Only the equations are included in your syllabus, not the proof. The proof will come in class 9. Right. Next topic is equation of motion. 3 equations are there. One equation we already studied. Equations of motion. Equation of motion relates the velocity, initial velocity, final velocity, acceleration, time and the displacement. The first equation which we already studied is V is equal to U plus AT. Second equation is S. Displacement is equal to UT plus half AT square. In case final velocity is not given, then you can use this equation. Third equation is V square is equal to U square minus 2AS. In case if initial velocity, final velocity, acceleration or displacement is given, then you can use this equation. In third equation there is no need of time factor, and in second equation there is no need of the final velocity, and if in first equation there is no need of the displacement. Whatever may be the question, according to that you can use any of the equation of motion. 3 equations are included in the syllabus. Only equations are included in the syllabus. Now the terminology are same as we studied previously, that is V is equal to final velocity, U is the initial velocity, A is the acceleration, T is the time period, and S is the displacement. Now what is one more term is there, that is acceleration due to gravity. It is not same everywhere over the earth. It is varying according to the places, but the average it is denoted by acceleration due to gravity. Acceleration due to gravity is denoted by small g. Right. In that case, equation of equations are modified as V is equal to U plus GT, equal to ut plus half gt square and v square is equal to u square minus 2gs, and it always act downwards, it is always acting in the downward direction, and its average value is 9.8 meter per second square in SI system, right? If we talk about in the CG system, its value comes out to be 980 centimeter per second square. And the term acceleration means A denotes that A is positive when the object is speeding up and A is negative when the object is speeding down. And in terms of speeding down of the object, acceleration may termed as acceleration is also termed as retardation or deceleration. Now the next topic is the graphical representation of the graphs, the graphical representation of motion. In the previous class, we already discussed one type of graphical representation of motion, that is distance time graph. Right? There are three more types of representations are there, but two are included in your syllabus. So we discuss only two over here. Topic is graphical representation of motion. In the previous class, we already discussed the distance time graph. Now, in the 8th class, the first is displacement time graph. Displacement time graph. As we already discussed in distance time graph, distance is plotted on y-axis and time is plotted on the x-axis. So in same as in displacement time graph, displacement term is plotted on y-axis and time is plotted on x-axis. Let me consider one example over here. That this is S is the displacement, 0, 0, 5, 5, S is in meters and T is in seconds. 10, 10, 10, 20, 25. So for the graphical representation, we draw two axes. One is x-axis, this is x-axis, and this is y-axis. Y-axis represents the displacement, that is in meters. Displacement, that is in meters. X-axis represents the time, that is in seconds. Right? Now, for drawing the graph, we have to calculate the difference between the maximum value and the minimum value. Maximum value and minimum value difference is same in case of this table for the displacement value and the time value. So we equally divide the excess 0, this is 5, this is 10, this is 15, 20, 25, 30, right? Same over here, y-axis 5, 10, 15, 20, 25, and 30. At 0 time period, displacement is 0. At 5 second, displacement is 5 meter. At 10, displacement is 10. This we draw like this. Wherever the point is meeting, that point is considered. Right? Roughly 15, this comes out to be a straight line. It means there is uniform displacement in uniform time period, right? It means that object is moving with a uniform velocity. That's why it covers an equal distance displacement in equal interval of time. Maybe the velocity direction may be changing, but that your object is moving with uniform speed. Now the significance of the displacement time graph. At any particular instant of time, we are able to find out the displacement. Okay. Suppose we have to find out that with the help of the graph, when we draw this graph on the graph paper, exactly, and we have to find that what is the displacement, what is the value of s at t is equal to 17 seconds, right? From the graph we are able to find out what is the value of displacement at time is equal to 17 seconds. Means to say that at any instant of time we can find out the value of the displacement, right? Second thing is the nature of the motion of the particle can be studied. Nature of the motion means if there is a linear line on the graph, it means that object is moving with a uniform speed. If there is difference curve or there is something like, suppose for some value the graph comes out to be a straight line, then we can find out whether the object is in rest or not. This we can get to know when we are doing a lot of practice over it, whether the object is in rest position or in motion position. ठीक है, ये हमें पता कब चलेगा, जैसे जैसे हम प्रैक्टिस करेंगे न्यूमेरिकल्स की, या फिर जैसे जैसे हम हायर क्लासेस में जाएंगे तो हमें पता चलता जाएगा कि ऑब्जेक्ट कब जो है वो, अभी तक हमने दो तरीके के ग्राफ पढ़े कि हमारा जो है लीनियर लाइन आती है तो इसका मतलब है कि ऑब्जेक्ट वो एक यूनिफॉर्म स्पीड के साथ मूव कर रहा है। अगर लाइन जो है दैट इज पैरेलल टू एक्स एक्सिस, अगर वो लाइन जो है वो पैरेलल टू एक्स एक्सिस है, इट मीन्स द ऑब्जेक्ट जो है वो किस में है, रेस्ट पोजीशन पर है, उसमें कोई मूवमेंट नहीं है। In case of displacement time graph, if we are seeing. Now the next graph is velocity time graph. Next is velocity time graph. ठीक है, अब velocity time graph के लिए भी सेम चीज है कि velocity जो है वो हम प्लॉट करते हैं y एक्सिस के ऊपर। वेलोसिटी की यूनिट होती है हमारे पास क्या, मीटर पर सेकेंड। सो हियर यूनिट कम्स आउट टू बी मीटर पर सेकेंड। एंड टाइम जो है वो वापस से हम प्लॉट करेंगे एक्स एक्सिस के ऊपर ही, और टाइम की यूनिट होती है सेकेंड। इन दैट केस लेट दिस इज वेलोसिटी v एंड इट कम्स आउट टू बी मीटर पर सेकेंड। यहाँ हम एक स्मॉल चेंज करते हैं कि दिस इज 20, ऑब्जेक्ट इज 15, ठीक है, 25, सॉरी मिस्टेक, एट टाइम पीरियड 20 वेलोसिटी इज 15, एट टाइम पीरियड 25 वेलोसिटी इज 15 मीटर पर सेकेंड, एंड इफ velocity time is 30 seconds, velocity decreases to 10, and if time is 35, velocity decreases to 5. Now this is 35, maximum time is 35, so we can take 5 seconds extra over the graph, that is 40. Here it is time, that is mentioned in the seconds. Okay, velocity maximum is 15, so need not to mention over 25 and 30 over. At 0 time velocity is 0, at 5 velocity is 5, at 10 velocity is 10, at 15 velocity comes out to be 15. Value as 1. Time period is 1 means something here. Right? At time period 20, velocity is 15. At time period 25, velocity is again 15. At time period 30, velocity is 10. And at time period 35 seconds, velocity is 5. So if we draw the graph, it comes out to be like this. Right. Now the linear line represents the uniform velocity, whether that is from A, this is A point, this is B point, this is C point, and this is D point. Graph AB and CD represents the uniform velocity. Significance of this: if the line graph is linear, then it represents the uniform velocity. The graph, the area under the graph means this portion, the shaded portion, this shaded portion represents the displacement which is covered by the object. Displacement covered by the object. This is the significance of the velocity time graph, that we are able to find out that how much object is displaced from its initial position. That is, the area under the graph is representing the displacement covered by the object. Now one more graphical representation of motion is there, that is acceleration and time graph, but that is not included in the syllabus of the class 8, that is included in the syllabus of the class 9. So there are 4 types of graphical representation we studied. Graphical representation of motion we studied. Distance time graph, that we studied in the previous class lecture, that is class 7. In the class 8th lecture, we discussed only 2 types of graphical representation of motion. One is the displacement time graph and the second is the velocity time graph. One more type of graphical representation of motion is there, that is not included in your syllabus, but the name of that representation is acceleration time graph. That is all about the kinematics for class 1. Now the chapter 1 is over. If you have any query regarding the kinematics, please post in the comment box. I will answer the query in the next lecture, next video. Thank you, and please like and subscribe the channel.